Data centers powering AI will consume more energy than entire cities. Modern data centers, which support the operation of artificial intelligence, AI systems, are increasingly becoming massive consumers of electricity. The campuses of these centers require up to 1 gigawatt GW of energy, which is the equivalent of the electricity consumption of 700,000 homes, or a city with a population of 1.8 million people. As the demand for AI continues to grow, so does the energy required to keep these centers running, raising concerns about the sustainability of power sources and the impact on the environment. The energy consumption of AI-driven data centers is poised to increase significantly in the coming years. These facilities require massive amounts of electricity, not only for computing tasks, but also for cooling systems to prevent overheating of the servers. As AI models grow more complex and require more processing power, the energy needs of these data centers are expected to rise dramatically. This surge in energy demand presents a challenge, especially in regions where electricity infrastructure is already under strain. In Arizona, for example, a new data center is being planned to consume 1.8 GW of energy to support 40 different facilities. This is a large-scale project that will put significant pressure on the local power grid. The center will require vast amounts of land, as well as access to reliable sources of energy. However, even with the rise of renewable energy sources, such as solar and wind power, these may not be sufficient to meet the growing energy demands of AI-powered data centers. Consequently, natural gas will still be needed to power these centers, which is problematic as it slows down efforts to reduce carbon dioxide, CO2 emissions. Natural gas, while cleaner than coal, still emits greenhouse gases when burned for electricity generation. This reliance on fossil fuels for powering data centers creates a tension between the need to meet the growing energy demands of AI and the global efforts to combat climate change. The use of natural gas in particular undermines the progress made in transitioning to a low-carbon economy, as the carbon emissions from these energy-intensive centers contribute to the warming of the planet. The challenges are not limited to energy consumption alone. Data centers also require vast amounts of land to house the servers and other infrastructure. In some areas, land availability is already becoming scarce, leading to competition with other industries and the encroachment on natural habitats. Additionally, the environmental footprint of constructing and maintaining these centers, including the extraction of raw materials for hardware and the disposal of electronic waste, adds to the ecological toll. To address these issues, it is crucial to develop strategies that can balance the need for AI-powered data centers with environmental sustainability. The integration of renewable energy sources such as wind, solar, and hydroelectric power into the energy mix of data centers will help reduce the reliance on fossil fuels. However, as renewable energy generation alone may not be enough, it is essential to invest in energy storage technologies and smart grid systems that can optimize energy distribution and reduce waste. Moreover, efforts should be made to improve the energy efficiency of data centers. This can be achieved by adopting advanced cooling technologies, optimizing server performance, and designing more energy-efficient hardware. Data centers can also implement strategies such as reusing waste heat for heating nearby buildings or industrial processes, further reducing their overall environmental impact. In the long term, the continued growth of AI and data centers must be accompanied by a commitment to reducing their environmental footprint. This includes finding innovative solutions to address energy consumption, land use, and emissions, as well as working towards a more sustainable energy future.